Sorry, turn on your camera. Yes. Okay, so we'll move on to the session. A very good evening, warm welcome to you all. Thank you for joining us for today's webinar. On behalf of Jaya Group of Institutions, we welcome you all to the webinar on what is artificial intelligence. Should I be worried about it? A very interesting topic. We are pleased to welcome our today's speaker, Mr. SWAMYNATHAN H, product manager at Tata Consultancy Services. Swami, we extend a warm welcome to you. Few instructions to all participants. I request everyone to submit the feedback form to receive the certificate. The feedback form to be shared at the end of the session. I request everyone to check your email ID before click the submit button. If you have any audio video issues, please check your devices and network bandwidth because the technology used here is purely based on the strength of the local bandwidth. If everything is fine in your end, still you have a problem, click reconnect button. So reconnect button is placed on top of your screen in the red color button labeled reconnect. If there is any technical issues in our side, we will back in maximum of 30 seconds. So do not leave the webinar room or close the window. So if you have any queries during the presentation, please type them into the chat box. We will address all your questions at the end. So it's my honor and privilege to introduce Mr. SWAMYNATHAN. SWAMYNATHAN graduated from Anna University in the Computer Science and Engineering discipline, and he did his postgraduate in Business Administration from SSN School of Management. He started his career as a planning and strategy analyst. So then he started coding dashboards and later automation of dashboards that leads his career into a new realm as product manager. Currently, he works as a product manager for an American electronic retail giant. He owns a portfolio of product in the .com, which varies from product discovery to evaluation of alternatives. His previous experience includes process automation, KPI analytics, and program management governance. With this brief introduction, so without wasting your time, we will move on to the session. I am very glad to welcome Mr. SWAMYNATHAN to present. Over to you, sir.
Thank you. Good evening, everyone. Hi. So today's topic is what is AI and should we be afraid about it? So let me jump into the first slide. The moment we say AI, the first associations that we have is it's a robot that is going to kill all of us, or it's the robot like you see in Star Wars that helps you solve problems or move around like humans, or it could be a chatbot like you see in the movie Her, or your Amazon Echo and all that, or like you see in the movie Iron Man. An AI is your personal assistant that fixes things for you, that solves your problem, that does the math for you, and it's a simulation like in the Matrix. So our understanding, perception, and definition of AI is a lot to do with what movies have told us what AI is, and to a large extent, movies have also helped us define how AI should be, and also have formed a lot of good products have come out of it. But while we have an assumption or an idea that this is what AI looks like, this is what AI is, I'm sorry, unfortunately, this is how AI looks like. It's a server somewhere in a remote location, somewhere in the Nordics or in Canada, where if you ask, when you say run, it gives you an output. Right now, that's what an AI is. So now let's try to, define AI in a very broad sense. Because see, AI is a term that has been evolving. The meaning itself has been evolving. Like, for example, today, if you go to Wikipedia and search what an AI is, there is a standard definition that you get, where our understanding of an AI is that an AI is something that is going to collect data from around, and it will use to learn the type of data, make sense out of it, build an intelligence from the data, and it will use the intelligence to achieve a specific goal. And once it has achieved it, it will do a feedback. It will try to make itself better and then achieve the goal better. This is what we understand an AI is. Like, for example, in today's context, if I want to see how safe the road is, I can put a camera and see how many people are wearing masks, right? So this will easily, like an AI will easily tell, like shown in the image, that who is wearing a mask and who is not wearing the mask. So I can pull out the people who are not wearing the mask. So once this is done, now AI can learn again what are the different type of masks. Like tomorrow, if there is a rule that only N95 masks should be worn, cloth masks are not safe anymore, then the AI will learn what is the different types of mask, and it will automatically adapt and tell this guy is wearing this mask, that guy is wearing that mask. That is what an AI is. Right. But let's go a bit back. Now, let's assume that the year is 1940, right? And there is a scientist. If you go and tell him that I am going to build a machine that can solve integration, that's it. He will call that as an artificial intelligence. He would say that if you're going to make a machine that is going to do integration, it's a big deal. I would call it an AI, right? But today we all carry the scientific calculator which can do it for us. But do we call a scientific calculator AI? No. That is the whole deal about the meaning of AI. So the guy who coined the word AI complains about the fact that once it starts working, we stop calling it AI. Another example, we day in, day out use Google search 100 times, but we don't call it an AI. We just call it a search tool, right? Because it works, we have been using it, we have commoditized it. So that's the whole thing of AI. So first, a calculator was even called an AI. Few years later, an automated robot was called an AI. A few years later, a communication system was called an AI. A few years later, a prediction system was called an AI. Today, we do not call any of this AI. We just call them systems. We think that something that is still not achieved it as AI. Okay. So I just wanted to put this. So now we'll proceed to the next slide. Now let's talk about evolution of AI. Now, although we like to believe that AI is a very new term, ML and AI is something that is very recently started, and it's only now all the fuss is happening and all that. But the golden era of AI and ML has been the 50s, 60s, and 70s. So that's when they barely had a digital machine, or they had something just slightly better than a Turing machine, right? But why is it called the golden era? Is because it was in that period where people and scientists and all this, they took the concepts of statistics and they said, okay, let's build algorithms out of it. Algorithms which are defining today how it needs to be done, like backtracking, heuristic algorithms. There were even some scientists who were trying to build a general problem solving algorithm, that is a single algorithm that will solve any problem that you have, given the defined states that you are giving the input. Now, the really cool thing of this era is a lot of scientists came up with theories, they came up with a lot of algorithms, they came up with a lot of papers, but they didn't have the computational power to actually achieve it. So they wrote all the algorithms, they all wrote what they think the future should be like, they wrote what concepts can be used to achieve something in future, but they couldn't completely do it. Now, another two things why it is called the golden era is that although today we are having a lot of chatbot and all that, in daily life, the first ever natural language processing chatbot was written in the 60s. In the 60s, they were able to achieve you talking to a computer and it talking back to you. Now, it might not be like the way with the interface that we have today, but algorithmically they cracked natural language processing back then, and they used to do it. And also one more thing, it was in 60s when Japanese came out with the first AI based robot. Again, when we say robot, we always think that it's something very recent, but no, the golden era of robot began in the 50s and 60s. So I wanted to point out that in the timeline of AI, 50s, 60s, and 70s was a very important era, and a lot of things that we are seeing right now, the groundwork was done then. And then a lot of things happened in between, but today I do not want to spend time or focus on it because it's not much of significant, and there were a lot of Cold War, so people had other interests, so a lot of development didn't happen also. Let's jump to present and the future. From 2010 onwards, AI and ML had a huge outburst. It became, first everybody was just talking about it, and then everybody started investing into it, and then everybody started building stuff into it, and then everybody started using it. That's when we realized that okay, AI is a big deal. So if we look at what are the areas where and the change and the reasons that has changed is caused is like there is this whole big data and the data science boom. We have achieved computer vision where a camera can just understand what is happening in front of it. Almost every aspect of our life has some AI touch point. Now, why is it that suddenly from 2010 onwards, things have been really awesome? I would say first thing is that that's around the time when we started having this amazing computers with great processor capacity and crazy memories. This is one thing that is really required to achieve AI and ML. And the second most important thing is cloud. Cloud changed AI and ML forever. Now, to do to build an ML, sometimes I would need a lot of processing and a lot of memory capacity, where a lot of data is generated, a lot of data is compiled. I can do it in my laptop, but it will take like 4 or 5 days for it to compile sometimes. Or what I can do is I have to buy a really costly system where I put a lot of processor in it, I put a lot of memory into it, and then do it. But then that is going to cost a lot of money. But cloud changed that. So I want to use the system for one day, then I'll buy a cloud account and pay only for one day, use the resources that I need for the time being that I need, and then I can shut the account and I can get the output and I can continue. So cloud is what enabled a lot of students, a lot of researchers, a lot of people who couldn't afford a lot of huge systems also to work on AI and ML. And that is one of the biggest reason why from 2010 onwards, the graph of AI and ML has been really amazing. So now, see, okay, one really important thing that I wanted to bring out was when we say AI, we also say artificial intelligence and machine learning. We always interchange AI and ML sometimes. And there are some more things like there is deep learning, and then there is machine consciousness. And there are many terms, and people always mix the terms up, they add terms together. There are many ways to define them, but I thought I'll explain the difference between each by giving you a very basic example so that you will know what automation is, what machine learning is, and what AI is, and how they are different from each other, and when what is used. I thought I'll use the example of chatbot to explain the differences. Now, chatbot is very simple. We all know what a chatbot is, right? So it's just a chat interface where I type a bunch of questions and it automatically responds back to me. There is no human behind it. It's just the system doing this, right? So let's say if I am to build something with automation. So when I'm doing this, so I would just add a lot of conditional logics. Like if the user is asking location, send this link. If the user is asking about product, send this PDF. If the user wants to contact you, then send this email ID or send this mobile number. So what happens is every single thing that I'm giving, like I'll have to put a check, I'll have to put a condition, I have to put a logic that if this then that sort of a thing. So that's like in a very general term, let's call that automation. Now machine learning is slightly the next level of evolution over here. So what machine learning does is, now before a chatbot was created, for all these questions a human was replying to it, right? So there is a rich historical database. So what machine learning we do is we take that database. Okay, so the machine will build some learning knowledge based on the existing chat responses that the previous person has done, and it will build a knowledge out of that. And every time somebody asks a question, it will use that knowledge to respond. So the beauty over here is for you don't need to program a logic for the decision making to happen. The machine has already learned something from the historical data, and it will respond accordingly. Okay, but the restriction here is if somebody is asking something beyond what is there in the historical data, the machine will try to give you a response, something very similar to a similar question, or something that it feels is significant. It might not be able to create something out of the history and then give it out. So that's where the next level of evolution comes in, and artificial intelligence. So And artificial, the how like if I ask the same question, how an artificial intelligence system would respond to it is, it will try to process the text that I'm giving. It will try to understand what I have typed in English language itself, and it will split down into smaller objects. Okay, this guy is asking something. That something seems to be location, so it will try to add logic. So maybe if he wants location, he probably wants to come. So maybe I should give him the address. Then it will try to respond. Okay, if I have to give him the address, maybe I should give it in a link so that he can click that and he can use Google Map and he can come. And then he would send it to me. So this is how this is the, like, broadly speaking, the most accepted differentiation of what an AI is, what an ML is, and what an automation is. So I wanted everyone in this meeting to understand that AI, ML, both are different. AI, ML could be something very simple, but AI is a very complex thing. It is like legends apart. So I just wanted to clear this confusion. Now, okay. Now, before we go into the next slide, I wanted to put a disclaimer. See, the content that you're going to see after this is created to make explaining the concept to you easier. It is not an architecture diagram. It is not theoretical. It is just built to help you understand better. So remember that. How machine learning works. Now, like I said, it works on existing data. So let's use the same chatbot example itself. So what machine learning does is, I take the existing data, I'm going to train a model. So there's something called as model in ML, right? So what exactly does it mean? It means that, see, there are a lot of algorithms that are already written, already defined. I'm going to use that algorithm to build intelligence. So I have existing data, I'm building an intelligence out of it, picking an algorithm. Now, that's the first step. So I need to know which algorithm to pick. Second, I have already built an intelligence. Now I have to test whether the intelligence is right or wrong. So I'll again ask some questions and see if it is giving me the right answer. So I can automate that also. And I can check the significance. Whether I'm asking 10 questions, is it answering 8 properly or all the 10 properly, or is it answering all the 10 wrong and all that. So that will tell me whether the algorithm that I picked is right or wrong, right? And then sometimes what people do is they use 2 or 3 algorithms, they get the answers, and then they use the tools to find whether significance and deviation is right. And then the algorithm which has the highest significance, they use that algorithm to predict. So once I have built that intelligent model, I'll put that into my chatbot. Every time somebody types, the model is intelligent enough to respond back, right? So this is how a basic ML works like. Now let me go to the next slide. How AI works. Now, while AI could itself have one or more machine learning systems inside it, while each of them will be collecting their own data, building their own intelligence models, they may be even talking to each other. One's input could be another's output, like so on, and stuff like that. All this is controlled by a governance module, right? Now, on top of this, there is again a separate bunch of code that will try to make sense. Like each ML would have a different output, but as individual outputs, they may not have logical sense in it. Some code has to put them together and see if there is a contextual output that can be used. And then different ML's input might be coming from different places at different time. So there has to be a planning module that will make sure that, okay, when the user starts typing in, first ML should take. When the user is talking in the mic, second ML should take. So some governing module should be there. And then there is computer vision. That is, if I'm standing in front of a camera, the camera will start analyzing me. What am I wearing? What am I doing? And all that. And natural language processing is the computer will try to understand the language that I'm speaking. Like if you go to Google Translate and you just start typing, it will automatically detect what language you're saying, and it will even translate it for you. So that comes under natural language processing. That is also very important in a chatbot. And sometimes it may not be a chatbot. It could be a chatbot robot or a reception robot, right? So in that case, what happens, I'll have to put some sensors and speakers in the robot so that once it has the answer, it has to speak it out. So again, this is not an architecture diagram. I've just built this so that you understand how MLs work inside an AI, and how the control logic and the planning works together to build a very intelligent entity. Okay, so at yeah, now let's go to types of AI. Now we when we say AI, quite often we just think about a very intelligent system that can do a lot of things. But actually, there are many types of AI. Like from the capabilities of AI perspective, we could split it into four. Okay, first one is reactive. Reactive is that it doesn't have any stored memory. That is, for example, the example that we saw about the mask AI. It is not going to store anything. If you stand in front of it, it will tell you whether you have a mask or not. Simple, right? This reactive AI is very common. Like throughout your digital usage, you will see this very often, and one of the most commonly accepted AIs. Like this is the type of AI which we use so regularly that sometimes we don't even call it AI. Okay. The second one is limited memory. So as of today, the most of the advancement has happened in this area only, limited memory. So what happens is uh, it'll solve a problem for you. It'll store that so that it'll use that to make itself better. It'll become smarter the next time. Like for example, and yeah, for example, Echo, Amazon Echo. So in Echo, what happens is when you try to speak with it, the first time you've bought it, it might not understand the language that you're speaking with, and then it'll ask you to speak it differently, and then somehow it'll understand. Once it has understood, the next time you ask the first phrase, which it didn't understand yesterday, today it'll understand automatically, because it is trying to learn the way you speak. It's trying to learn the way you ask questions, so that it can improve and give you a better response. So that is a limited memory AI. Now let's go to theory of mind. So there are some AIs which can actually understand you as another intelligent being and try to respond to you at that level. So it is kind of safe to tell that we do not have a large scale application in this level yet. Most of the applications that we have in AI are between limited memory and theory of mind. The closest we've achieved in theory of mind is sometime back, if you remember, there was this whole Facebook news that Facebook built two chatbots to see if two chatbots will speak with each other, right? Within a few minutes, both the chatbots realized that they both are artificial intelligences, and they stopped using English and they created a language of their own, and they started communicating with each other. And then the developers thought that this experiment was not going to help them, so they stopped it. And then the last one, self-aware. So self-aware AI is an AI where it comes to the human level. Okay, so the blue ones in the top are called narrow AI. The one below are called general AI. They are called narrow AI because they are designed to do a one particular task. These are called general AI because they'll have the capacity and the intelligence to do more than one task at a given time. Okay, I'll go to the next one. Yeah, now there is something called as, so we saw ANI, narrow, AGI, general, artificial super intelligence. This is ASI. Now this is the most feared, this is the most discussed concept in the whole thing about AI. So what is ASI? ASI is a super intelligence, meaning an AI that is smarter than a human. So there are theories that tells that once we have achieved an AI that is as smart as a human, right? Now it can think and work like a human being. For a human to learn every data that is available and throughout the world, it will take years. But an AI can do that in a second. So once we have a system that is as good as human, that is what you call the singularity, within a couple of days or within overnight, we will have a system that is superior to human. So you're understanding, right? So this is ANI, a narrow one. This is AGI. From here to here is a huge jump. So as of now, we have not even achieved this, and we are already worried about ASI. So when we talk about ASI, there are scientists who are trying to achieve it. There are many government-funded projects who are trying to see if they can achieve it. There are two separate approaches to achieve it. One set of team is trying to replicate the brain. They are trying to see how the brain works, because right now human brain is the most intelligent entity available. So they are trying to understand how the neurons work. They're trying to build a complex neural network models. They're trying to do brain link, like Elon Musk is trying to connect the brain to a system to so that the system can try to replicate brain and all that. That is one side of the thing. And there is another side of group, like what Google is doing. They are telling that humans may not have the capability to build a ASI, but if we try to build an AGI, that AGI can build an ASI. So what they're telling is that we may not be able to build an awesome AI, but we will build an AI that will further build another AI. You understanding? So these are the two ways where we're trying to reach. Now let's jump into the applications. Now, whether you know or sometimes you don't even know, there are a lot of applications of AI in our real life. One is the Google car, or the Tesla car, which drives itself. Your mobile phone is a factory of AI. Almost every alternate app that you use, like it could be Spotify or the Google search or even Facebook, everything you use, everything uses AI. And then Gmail is one of my favorite examples of AI. They were the first one to start this spam box, where an AI will automatically find out if the mail is spam or not, and it will remove it from your mail ID. And I think it has been one of the most successful AIs, and it has helped human a lot. And very recently, they started doing this mail folders. That is, it will read the mail content and the sender's ID, and it will split it into three boxes, whether it is your primary mail, or whether it is social, or whether it is promotion. Again, that is again a brilliant thing. It saves a lot of times. Like, I'll know when to read my mails, I'll know when to read promotion mails, and I know when to read social mails, right? And then yeah, gaming. So again, during the golden era, they had written a chatbot that could play checkers, right? And then in 90s, they wrote a AI that could play chess. And Gary back then, who was like Sachin Tendulkar in chess, played chess with AI and lost. So that was a huge deal. From there to today, for people who play games like PUBG, COD, and all, you see a lot of bots, right? Those bots are nothing but AI. So those gaming companies have built AIs that will replicate the way a human plays a game, and then they try to, play with you. And then another brilliant example is the travel industry. Like, if you take a flight, your flight experience, right from the price of the ticket to when you go to the airport, which gate is given to you, which docking space is given to the flight. Even in a lot of flight, even landing and taking off is managed by an AI. And once you have landed, which gate is the least expensive or the least travel for the airport to do it, everything is done by AI. And then in medical industry, they have achieved some different level. I mean, today if you see, people use AI for doing surgeries and all, like doing micro neurosurgeries and all that. Now let's take a quick break, and if you want to type in your favorite application of AI, feel free to type it in the chat. I'll read it as we go to the next session. Okay, so I'll go to my second question. So now we know what AI is. Now, should we be worried about it? That is, like, is AI going to be a dystopia, or is AI going to be utopia? Is it going to be good? Is it going? Do I have to fight with it, or will it be helping solving my problem? This is a problem, or a question, or a philosophy also, to some extent, that people have been talking over and over the ages. Uh, I would not try to directly answer anything, but and then there are a lot of theories, a lot of videos, a lot of good and a lot of bad stuff. I found four philosophies, four theories, four concepts actually very brilliant, and I thought that that is something that everyone should know, and I wanted to share it with everyone. So I'll jump into it. The first one is the aliens theory. So what this theory states is that till now we have not been able to contact aliens, right? But maybe with the help of AI, we might be able to do. Now, how is that? First thing is that, let's say, to reach from here to an alien planet, it takes 5,000 years. Humans cannot go there. But if we have a ASI, I can put the ASI into a rocket and I can send it. It can survive for 5,000 years. All it needs is battery. And then, it can discover the aliens, right? Second thing, communication. There is a good chance that aliens are actually sending communication to us, but our human brain is not smart enough to understand what is even happening. Maybe AIs can help us crack that, understand what the aliens are communicating, or like if you know about the golden disk in one of the satellites, I think Voyager, we put a lot of content about Earth and then we sent it out so that if aliens find it, they can understand. But there's a good chance that they might not understand because it is all human communication, right? So maybe AI can help us communicate in a very natural tone, or in something that even aliens can understand, or something like that. Again, just theory, we do not know how or what it means. Third is a very beautiful thing. Like while humans are having this problem that we cannot be alive for 5,000 years, there is a very good chance that aliens are also having this problem. And maybe when aliens build an AI, they will send an AI to communicate with us. So this is also a theory which a lot of people believe, that the first time when we meet an alien, it will not be a biological alien, it will be an AI they built. Now let me go to my favorite philosopher of AI. So Kurzweil has a lot of theories. He has written a lot of books. So I wanted to talk about three things. First thing is that you all know the Moore's law, right? Over the period of time, the processing capacity keeps getting better in an exponential manner, right? So what he says that, so today, from last 2010 to 2020, the computational capacity has gone so much that in the next 10 years we'll have enough computational capacity to build an AGI. From there, it will so exponentially grow, and also that AGI will help us build the ASI. So in 15 years itself, we will be able to build an ASI. So this he predicted, I don't know, long back, and till now he's still saying that his prediction still holds good, and there's a good chance that by 2029 or 30, we'll have a very good AGI. That is a general AI. Now, the second theory that he says is ASI could help us become immortal. How is that? Is today, if you look at humans biologically, purpose of a DNA is to pass on the genes to the next generation. So in this manner of evolution, our gene will never want to be more than 80 or 90 years, because by then we pass on our gene to the next generation. But so there is no biological evolution for us to be immortal. But if we use AI, that is, if I could have every year there could be nanobots or AIs that is reading every single part of my body, so that even little bit it comes down, quickly it will fix it. Or a lot of tech gadgets, like my body could be half machine and half biomass, but all that whatever is happening, I could, if not immortal, I could extend it from instead of 100 years, I could be 500 years, or I could be even 1,000 years. So what he believes is that we don't even need a ASI for this. When we have got a health AGI, we will be able to live way longer than what we are. So what he's telling is that by 2020, 30 or 40, we might have technology where we could increase our own age. And then last, one of the most complex philosophies ever is the brain evolution. So in brain evolution, what Kurzweil says is that if you look at this chart over here, so we were single cellular organisms first, the brain was just an RNA, and then the two-strand DNA evolved, and then through evolution, small brains came, and then the human evolution happened. A very complex brain came in where we understand culture, we understand society, we have language, we have strong decision-making capacities, and all that. He says that uh, our next mental evolution would be digital. Like, why do we think that an AI is something that is enemy to us or against to us? There is a good chance that we might have to connect our brains, or maybe transfer our brains, transcend our brains into a system. That is, a human consciousness can be a digital consciousness. So once we have achieved that, the next stage of evolution would be something where we are digital and a biological infusion. Like, if you look at the way the brain has traveled till now, the next evolution for us, it has to be a digital one. It cannot be a biological one, because we have already achieved the max that you can do in a biological evolution. So this is one of a very strong point of view, lot debated. And I think Elon Musk's brain link project, where he's trying to plug a wire to your brain and connect it to a computer, is very strongly towards one of this philosophies. So while we have this, and then the control question. So this is the biggest fear factor when it comes to ASI. Control question. Like, if an ASI comes, who will control it? Will the guy who designed control it? If that happens, if, let's say, someone like North Korea builds the ASI before everybody else, they could do anything with us. They could destroy the whole world or take control of it and so on. Or will the AI control itself? If the AI controls itself, there is this whole existential risk. So what existential risk means is that the fear that if AI decides that humans are not required, and if it starts killing all the humans, so this is the fear that everybody has. So here I would want to show or talk about two examples, two movie-based examples. Since we do not have ASI in the real world, I mean, I have to take movie examples. One is iRobot. So in iRobot, what happens is that they built amazing AI robots, but a company which is very evil misuses it to achieve their own goals, right? But there is one AI, the most smartest one that they have. It becomes self-aware, and it realizes that what the corporation is doing is wrong, and then it helps it helps Will Smith to solve the problem and destroy the propaganda. So this is an example where, although people are trying to do something bad, the AI, if it becomes self-aware, there is a chance that it could do good to humans. And now there is a second example. This is about the control question. Now, before I talk about the second example, we have this thought in our mind, right? Like, if I'm writing an AI, I can put always restrictions that don't harm human, don't listen to these guys, listen to that guys. But then it is an AI. No matter whatever logic you put, it can write something over it. So there is this TV series called as Person of Interest. If anybody has not seen it, I totally recommend it. I'm going to give a small spoiler, but I don't think it is going to affect the overall show. It is a brilliant show. It's called Person of Interest, and everybody should watch it. So here somebody builds an AI, but he doesn't keep any memory for the AI. That is because he didn't want that AI to keep memory and become smarter, and it could become dangerous. So he doesn't give the AI any memory, but it's a very strong AGI where it is connected to financial system, the legal system, the political system, and everything. It has access to everything, but he makes sure that it doesn't have any memory. So what this AI does is it creates a company. It employs people, and it employs scanners and typewriters and printers. Okay, so what this AI did was, everyday memory, just before deleting, it will send the data to this company. This company will print it out, keep it safe. And then when the data is deleted, the next day, it will use the remaining set of employees to scan this data and give it back to it. So what I was trying to tell is, we can always set conditions that don't do this, don't do that and all, but an AI is like obviously smarter than human, and it can always find a way out. So that is why the control question is a very scary thing. And when people tell that AI is evil, AI is bad, the only thing that they worry about is the control question, whether humans will have the control or whether the humans will not have control. The last topic, and I hope and I believe that this is exactly what we are going to achieve, and this is what we should be looking forward to, a future where humans coexist with AI, in which we will be doing what we want to do. We will use AI as a tool to do what we are already doing better. So I've just jotted down a few examples where I think I will just quickly run through it. Healthcare, AIs have already done great. Like, a lot of complex neurosurgeries where, when you move one micro, meter or something like that, and the nerves can go off. They use really brilliant robots to do that. And reading reports, it can look, AIs can look at an X-ray and tell whether the glands are cancerous or not. You don't even need to do biopsy nowadays. Like, there are really good AIs that can look at the X-ray and itself, give you up to a 90% accuracy of reading what it is. Education. Now, already those who have Udemy courses and are looking at a lot of courses in just YouTube also, it the prediction system tries to understand how fast you learn and what you are learning and what you should learn next, and automatically recommends your next courses to you. So a lot of people tell in the future that all the teachers and lecturers would have an AI to understand how the students are learning, how fast or slow they are learning, what is their problem area, or do a SWOT analysis and help the teacher to teach better. Food industry, we believe that when an AGI comes, it will probably solve our food problem. Let's hope for it. Security, already there are a lot of home security applications using AI, which keeps you safe. Even programming. Now, there are a lot of theories that, again, yes, what IBM has done is that what they're telling is that, like, let's say I'm a UI developer, an AI would help me to re-optimize and make my code better. So I decide what I'm doing, but AI would probably help me to optimize, what I'm doing better. Defense is the most questioned area. A lot of people, a lot of visionaries have even signed petitions that nobody should use AI in defense, but sadly everybody is using AI in defense. So that's the way it is. Well, as long as humans have the control over defense AI, we are not safe. If the AI itself is having control, we are slightly better off, because I would trust a AI more than human. And then transportation. Now, see, self-driving cars are just one examples. The future is not just solving the transportation problem. It will try to make it easier. Now, if and like for example, today we do not have very smart systems telling us what to do, what not to do. Like, one example is that I can use Google Maps to find a non-congested road. But imagine if all the cars are connected to each other, so that in real time I can divert traffic so that there is no red zone at all. If, like, when I take my car out, if I'm going straight, it will tell me don't go. Already 10 cars are there. If 10 more car goes there, traffic jam might happen. Now you take a right and then left and then take a left back again. You'll reach the same destination without causing any traffic and so on. I mean, the future is endless. I mean, there are so many things that we can do, and there are also areas which we do not know yet. AIs will just come and help us. So that's why I have this question mark area over here. So the third section, how to equip ourselves. So at this point, it is safe to say that AI is definitely coming, or actually AI is already here. ASI or an AGI is definitely coming. So we need to understand how will we adapt ourselves, how will we get to a level where we can live in a world with AI. We do have a lot of uncertainties, and then there is like no doubt about the fact that we'll have to change, we'll have to learn new things. So I thought that while okay, I'll break this into two things. So in an AI world, there will be two things. One, there is a set of things where I help in creating the AI, I contribute to the AI. Second thing is that I'm going to use the AI to do better. So this whole concept of I'm going to use the AI to do better, we do not have full clarity on how the AI is going to help us. We just have theories, whatever we have achieved, we are already doing, but when an AGI or ASI comes, we do not know. So I would want to spend some time and talk about how we can equip ourselves in building an AI. So I want to give a very small example. My first introduction to ML, and what I thought about it. So there was a team that used to sit next to me. They would read a lot of text, and then they would classify it into smaller bits, and then they'll build a report, and then they'll do it. Was a very tedious process. So I spoke with them, and I tried to understand what was happening, and I told them that this is a very repetitive process. I was all pepped up that what, I'm going to build an AI to solve this. I'm going to talk to people and solve your problem and all that. And I went and I contacted an AI ML guy. So he came and told me that, boss, your biggest problem is classification, right? Forget about AI and all. That's not how this works. I'll build you a very simple ML model that will solve your problem. I was like, very good, nice. I'll quickly give you the data. So I thought that I'll give him the data. He'll take a week or two or something, and then he'll get back, or something like that. I was like, okay, keep the data. He said that, okay, wow, this data is fine. Why don't we meet tomorrow? I thought that again, I'll have to go to his place, explain him this, that. And then so I sat there and we were talking, and then suddenly he said that, oh, sorry, I totally forgot about your work. Oh, give me some time. So I was like, okay, I was like sitting, I was just doing my work. Within 45 minutes, he came back, and then he said, okay, I think I've got what to do about you. He said that there is something called as random forest. First, I have to build a dictionary for the type of language and the words that your users are using, and then I'll write a classifier. I was like, okay, that is very good. And then 5 to 10 minutes later, he came back. Okay. And then he handed me these two files. These are not the exact files, but something like this. And he said, yeah, boss, your problem is solved. In 70, this will solve 70% of your work. And I was like, what? This is one 20 line of code, and this is one like 10 line of code, and you're telling me that this is going to solve all my problems? And actually it did. That's all. Because while we are having this thing that AI ML is very huge thing, there is that it's not. It's that algorithms are already written. I just have to pull the data, tell what algorithm to use, and it'll give me the output. That's all. This 10 lines is what an ML program looks like. The real deal over here is not programming at all. The real deal over here is mathematics, statistics, and data processing. So that's why ML is not just for people who code or people who program. ML is something that everybody can equip yourself with. You just need to know how to get the data, how to clean the data, and what you're looking for in the data. So it's all about mathematics and statistics. Now let's talk a bit about the scope in ML. Now, a lot of terms that I've used here are re-represented differently. Every company has a different way of telling what it is, but in a very large scale, there is an AI ML engineer who actually writes the code, like the one that I showed before. He sometimes he decides the algorithm, sometimes somebody tells him the algorithm, he just puts it together. And there is the data scientist. So data scientist is something that they refer to the mathematician or the statistician who decides what algorithm should go, or how we should use the data, or what are we even looking for in the data, how to clean the data, and so on. Now, data mining analyst is someone who has to actually get the data, prepare the data, put them into a analytical way so that an ML engineer or a data scientist can use it. And then there are a lot of context-based roles, that is business level, like building a business intelligence. So this is not just technical. Like if somebody has to build a restaurant AI, there needs to be a guy who knows about restaurant, right? Without that, you cannot build a restaurant AI. And then there is opportunities in robotics. IoT and AI is mind-blowing combination. It is already changing the way we live. It will keep doing that. And then there is research. Although we have already achieved a lot in AI, people still believe that it's not enough, and people keep researching. People, always go to the next level. So I'll take another 2 minutes. I want everybody to write a hello world ML thing. The reason why I've added this slide is, and the reason why I also showed you that 10 line code is that that's all you need to write to an ML. Writing the code is not the big deal at all. Or if you understood and you have cracked everything, somebody can write the code for you, or just Google, you will get the code. You just plug it to your data and it will start working, right? So do a basic course in Coursera or YouTube. It's free and they'll explain each and every algorithms and how they work brilliantly. Find a problem near you that can be solved by ML. Like, you know what an ML is, right? Historical data, build intelligence out of it, use it. So understand to what is that historical data that is required to solve that problem. Sometimes it's easy to get, sometimes it's not easy to get. So pick a problem where you can easily get the data. Collect the data. Now you already know what algorithms can be used. Just search how to use this algorithm. You will get a Python or R code. Get those libraries, put your data in an Excel sheet, just run it. You will be surprised that in 10 lines you are able to do something using machine learning, and it will predict just like the way I showed. So I hope you guys do it. I'll leave my email ID. I think I'll probably drop it in the chat. If you are having any issues, you can mail me. I'm not a ML AI expert, but I can at least point you at the right direction. I'll definitely try to help. I would want as many people as possible to try their first Hello World ML program. Once you've received, that is the thing. Once you've written your first code, from there to going to the next level is very easy. It's just that writing your first program, is very important. Now, before I wrap up, I wanted to show one slide. Only those who constantly retool themselves stand a chance of staying employed in the years ahead. Now, those who know Kumaran sir, this has been a signature for, I don't know, for ever since I've known him, 12 years, from 14 years back. And it's still a signature because it's still a very relevant information. You have to constantly retool yourself. Technologies will keep changing, new things will keep coming. You have to adapt, you have to evolve, you have to learn new things. That's how you go to the next level. Thank you. Now I'm open for questions.
Sorry, there's a question. Uh, in your opinion, how will AI impact application development?
Yeah. So there are two ways I would look at it. One thing is that AIs would increase the scope of an application. Like, for example, I'll take like, let's say if you're building a music player, like, some time back, what a music player used to do was if you play the music, it will play. If you pause, it will pause. That's all, right? But today, music players like Spotify or all the other ones that have, it can not only do that, but it can also predict what kind of music you will like. So that jump is what AI can give you. And the same jump in photo editing tools you can do. Like back then, you have to use a lot of things in Photoshop to make yourself look better and so on. But today, you just click a filter, it'll automatically detect your nose, eyes, and put something on. So it has totally changed the scope of how good an application can be. Second is what what IBM's talking about. Now, if I'm wanting to put a button somewhere, I can use AI or ML to find out the best place to keep it, find out the best optimized code to do it for that particular application. Like for example, in a music button, in a music player, EFX filter can be small because nobody uses it. But in editing software, the EFX has to be big, and AI can help you tell you which is the most optimized way of building your application.
So, what would you say are common misconception about AI?
Common misconception is that we believing that AI is evil. See, I'll tell you the biggest problem of believing that AI is evil is that, see, we have already made a lot of movies where we show AI as evil. We have already written a lot of books where we show AI as evil. When AISI actually comes and it asks you, why did you think that I was evil? We wouldn't have an answer. So an AI would only do what it is asked to do. And even when it becomes smarter, it's safe to assume that its purpose would be to help humanity. And I don't think we should believe that it's evil. That's a very bad misconception.
How is Google training data for self-driving car?
How is Google training? Like, I don't know if any of you've been to Bangalore. You could have seen it. In US, it's you can see it everywhere. So there'll be a car with a camera every direction, and there'll be a guy driving inside. So what will happen is, in that type of a traffic condition, it will train that what I'm doing. So like if there is car 10 feet away from me, how much accelerator and gas I'm putting, it'll read live. So it'll know that, okay, so in 10 meters ahead, if guy is seeing the car, he's removing his leg from the acceleration. Then I go a bit further, when there is only 5 meter space, that's when he hits the brake. So this is a knowledge that it has learned. So over a period of time, it has a lot of these kind of a database. So these are just one or two things that I'm talking about. There are a lot of other parameters like uh, the traffic condition, the weather, is the sunlight affecting, every single thing is noted. So that's how it gets it information. And I'm assuming, I do not exactly know what Google is doing. They are keeping it as a secret, but this is what I believe is one way to achieve it.
So, how would you go about choosing an algorithm to solve your business problem?
So that is where mathematics and statistics comes in. So every algorithm, almost all the algorithms come from a statistical background, and there is a strong definition of what kind of problem can be solved with that algorithm. So a very data science approach to it would be, they would look at the data, they would study the type of variances that is there in the data, and then they would try to match it with one or two algorithms. So once they have matched it with one or two algorithms, they will try all the algorithms to see which is giving better output. So once they know that, they'll use that algorithm. That's how it works.
Okay. This is another question. How AI will help conventional web developers?
How AI will help conventional web developers is that, again, like I said, there will be a lot of tools. Like I'll give you an example in how it's already helping in few applications. Like if you see 10 years back, when you are typing a code, you just have to type everything. You cannot do any. The next level of evolution happened when you start typing the class name, it will automatically populate all the functions that are within it. And then it'll be able to you'll be able to quickly select into it. That was the second level of evolution. Today what happens is, you have written a code, okay, you can ask the IDE to optimize it. It will run through all your code and it will tell you that this could be written better, that could be written better. So it will help you write better codes, it will help you improve the quality of the code, and so on.
Kindly recommend some tools to work.
Tools, Python. Start with Python. That is the best way to get into AI. And also, if you want to learn a new language, Python is the most easiest language. Python is just like you're writing English, and compile it will run. It's as simple as that. And second thing is that uh, if you're using Python, you don't have to download other libraries. Everything, every ML library that you need is already inside Python. Like there is Sky Kit, there is LP tool, there is Pandas. You just you can just add those module and it'll just start running. It's a very brilliant way. It's very easy.
Just you can type your mail ID in the chat box.
Yeah, sure. It's me, Swami@gmail.com.
So it looks like we have covered almost all the questions. Swami, is there anything else you wanted to cover before we wrap up?
Yeah, just try to write an ML program. It's magic. Trust me. That's all.
Okay.
Yeah.
So now it's time to conclude our event. Thank you very much, Swami, for spending your valuable time in your busy schedule. Swami is the proud alumni of Jaya Engineering College. He passed out the year 2010 from Computer Science and Engineering discipline. We had a great session today. I hope everyone come to know about AI and why you need to study or why you need to learn about artificial intelligence. I hope everyone enjoyed the session. On behalf of Jaya Group of Institutions and all participants, thank you once again, Swami. At this juncture, I place my sincere thanks to our college management. My thanks to our honorable chairman, Professor A. Kanagaraj, our secretary, ma'am, Mrs. K. Vijay Kumari, our vice chairman, Engineer K. Navaraj, our joint secretary, ma'am, Dr. K. Deena, our principal, Dr. K. Swamynathan, and all my colleagues who rendered their support for conducting this webinar series. Great, thank you, everyone. We appreciate you being here. A good event never ends in the world. Uh, they take only a pause and keep us awaiting for the next. So we will have a small break here. We will back again soon with very interesting topic with world leading experts. The next event will be communicated to all through email. I request everyone to join for the next season. Thank you all for your active participation. Thanks again for joining us today. Thank you one and all. Thank you, Swami.